physics, Newton's laws, P22E, use vector diagrams to show equilibrium situations and let me change this. Situations and net force non-equilibrium situations. Now I'm getting back on the pictures from Newton's first law. Equilibrium situation or situations is the situations when forces cancel each other out and there is no resultant force. That means no acceleration. This is related to Newton's first law. We can say, okay, there is a book, weight going downwards, normal force going upwards. We see the size of those forces are exactly the same. They cancel each other out. Now, if I was to push on this book to the right, and the book would not be moving, that would be because another force would be pushing it to the left, friction, and will prevent it from moving. The instance with an airplane, well, the same, this is an equilibrium situation. Remember, we always look at pairs, that means up with down and left with right. We're never going to look at up with left or at down with left or down with right or up with right. It's always the ones that go in the same direction. Looking at lift and against weight, well, we see that the arrows are exactly the same. That means they have the same value, they're balanced. Thrust with drag, again, the arrows are exactly the same value. That means they must be balanced. This is equilibrium situations. The airplane, nor the airplane or the book are accelerating. They're not going faster or slower. Right? In case of the book, the velocity is 0, but that still doesn't mean it doesn't go faster or slower. It means it stays at 0. And the airplane, well, it depends on what speed the airplane is traveling with. Now we have here two people doing an arm wrestling. Now, force to the left, we obviously see it's larger. The blue force is larger than the red force. There have been 6 newtons going to the left, only 3 newtons going to the right. Here, this is a non-equilibrium situation because those two forces are not equal. So that means some forces are bigger, stronger than others, and there is a resultant force which creates acceleration. Well, what does it mean? Well, it means that unbalanced forces, that means forces are different, creates acceleration. Acceleration means what? Well, an object can be going faster, and this is called as acceleration, or an object can be moving slower, which can be also called as deceleration. So in this situation, the overall between these two forces, the resultant between these two forces is that the blue force wins, and then it wins by 3 newtons moving to the left, because that's the difference between the initial 6 newtons and the 3 newtons going against it. Again, we're back in non-equilibrium situations, unbalanced forces. We're going to take the situation when we have acceleration, when the object is moving faster. Well, this is happening always when an airplane takes off. It's an acceleration, because if we look at this diagram, we see that the thrust and the air friction are the same in value, but the lift is going to be larger than the weight pushing downwards. So that means if the lift going upwards is larger, so the force of lift is larger than the force of weight, in this situation the airplane will accelerate upwards. Well, that's the whole purpose of an airplane taking off. You accelerate, you want to reach up in the sky. So again, non-equilibrium situation. Some forces are bigger, stronger than others, and there is a resultant force which creates acceleration. Let's look at a deceleration situation. That means an object is going to move slower up to the point it will reach it will reach rest. So in this situation, we see the cyclist is the bicyclist. There is a force that's pushing the bicycle forward, well, from his feet, but at this moment he's pushing the brakes, and then there are forces stopping the bicycle, like the air drag and the friction with the ground, which are much larger than the forward force. In this situation, the friction, the braking, is larger than the push force, and the cyclist brakes, and eventually it will stop because of the deceleration. Because deceleration means that the cyclist will move slower and slower up to the point it will reach rest. It will have no velocity left. Non-equilibrium situation, again, some forces are bigger, stronger than others, and there is a resultant force which creates an acceleration. So we have balanced forces with no acceleration, and we have unbalanced forces with acceleration.